Hello friends, welcome back. This is part 3 of the Vedic math series. In previous parts, we have covered multiplication and proportionate multiplication, where both numbers were kind of close to any power of 10 or assumed power of 10, which is our the new base. In this part, we will cover 3 special scenarios. So let's start with scenario 1, which deals with squares. So as you can see here, we have to do a multiplication which is square of 93. So the way to do is here the deficiency from the base, let's say 100 in this case, is 7. So the right side portion is the square of the deficiency. So that's 7 into 7 gives us 49. And the left side portion is reduce the deficiency from the number itself. So that is 93 as the number minus the deficiency gives us 86. So the final answer would be 8649. Let's look at another example. The numbers are 991 and 991. So the deficiency from the base 1000 would be 9. So the right side portion is 81 because it has less number of digits as compared to the number of zeros in the base. So we need to precede it with a 0 to make it up. And the left side portion would be 991 minus the deficiency, which is 09, which gives us 982. So this gives us the answer 982081. So the two rules to remember if we are doing a square of any number, doesn't matter how big it is, which is closer to any power of 10 base, is square the deficiency and reduce the deficiency further from the number itself. So with these two rules, you can do any number, any square pretty much mentally. Let's look at another case. So this is a special case wherein the sum of right side portion of digits is 10. So if I write down like this, so 15 and 15. So the way to do is the right side portion would be the multiplication of the two digits whose sum is 10, or 10 would be better. If you go for the 100, then the multiplication itself would be difficult. So let's assume that it has to be 10. So the right side portion would be the multiplication of those right side digits. So in this case it would be 25. And the left side portion would be the multiplication of the number itself with a one higher number. So in this case it would be 1 into 2. So I'll write it down just to make it simple. So that gives us 2. So the answer would be 225. Let's look at another example. Here numbers are 115 and 115. So for the right side portion will be 5 times 5, which gives us 25, and the left side portion would be 11 multiplied with the next high number 12, which gives us 132. So the final answer would be 132.25. Let's look at another example. Thing to notice here that in the previous two examples, the right side digit was 5. In this case, these are not 5, it is 7 and 3, but the left side numbers are same. So the formula still applies. So the right side portion in this case would be 7 times 3, 21. And the left side portion would be 2 times next higher number 3, which gives us 6. So the answer would be 621. Let's look at another example. 74 and 76. our condition matches, that right side numbers adding up to 10, so the formula can apply. So the right side portion would be 6 times 4, 24, and the left side portion would be 7 times 8, which gives us 5, 6. So you don't need to even write it down. You can just look at the numbers and just do the multiplication of the right side numbers and the left side numbers pretty much orally. Let's look at the third case now. So third case is wherein we have to multiply with number 9. It can be 1 9 or a chain of 9s, but the principle holds true. So in this case, the technique is that, all right, if we write down numbers like this, 78 multiplied with the 99. Actually, it's you can say that it's a slightly special version of the technique that we learned in part 1, because in part 1 it was like we have to do the deficit from the base 10. So but here the base 10 is already kind of given because it's 99, so base is pretty much 100. So if we just recollect the technique, so if you have the number available, then the what you do that you write down the deficit on the right side of the numbers. So in this case it would be 22, and let's say the multiplication gives us 22 for the right side portion. What it tells us that if you have to do it like without writing down all these steps, that if you have that base available, which is like the next which is just one addition to the series of 9s which are available in the multiplier. So what you need to do is that go to the base 10 and subtract it from the second number. So in this case 100 minus 78 gives us 22. So that's our right side portion, and the left side portion is nothing but the cross subtraction. So 78 minus 1, which gives us 77. Now if I remove these steps, so the way to do it would be that the right side portion would be nothing but the subtraction off from the next higher number available, which gives us 22, and the left side portion would be 1 less than the number itself, so 77. So the answer is 77, 22. Let's look at another example. 88, 999. In this case you would have noticed that a number of 9s are increasing. So again the same technique applies. So the power of 10 would be, in this case, would be 1000. So the right side portion would be 1000 minus 88, so which gives us 912, and the left side portion would be 1 less than the number itself. So the left side portion is 87912. If we look at another example with more 9s in the series, so 81 multiplied with 1 2 3 4 5 9s in this case, so our right side portion would be 999, and because we have to reduce 89 from the, in this case 100,000, so 999 19, and the left side portion would be 1 less than the number itself, so 8099919. So that's our final answer in this case. So same way this technique can be applied to any number where one number is nothing but number of 9s. In the next part of the video we will cover the generic multiplication principle, which is kind of like an all-purpose formula for any two numbers which are anywhere, doesn't matter whether they are closer to any power of 10 base or any other variation between. For the time being, practice with numbers of different types covered in this and the previous two parts, and see you soon in the next video. Bye for